Hi everyone. So I'm Chester. I'm from SUTD, and today I'll be talking about this very cool piece of technology that I picked up from my internship experience, and I'm here to share it with you to learn more about this technology. It's called Ansible, and I'll also be showing you about some examples on how you can use it on the Google Cloud platform for your own projects. So where did this come from? As a sysadmin or the infrastructure guy in your team, you might have ran into this problem before. You have a lot of servers, and then you need to update every one of them, and you need to manually SSH into each server, and then you upgrade the packages. Then you have 100 servers, you need to do it 100 times. Or sometimes you need provisioning or setup scripts to install all the software you need, or like configure the hosts, such as setting up firewall rules or creating users and groups. But then your scripts start to get very long and very hard to manage. And then if you have you're managing multiple hosts, right? And then if you have many hosts in your corporate infrastructure, and then you're creating you need to create like what each host you have, you create an entry in your SSH configuration file, and it gets very long and hard to manage. So if you have faced this problem before, I'm here to introduce to you this technology called Ansible. Ansible is an IT automation framework that can handle a lot of things. You can do host configuration, and it can also spin up new infrastructure, like creating new VMs on GCP. So essentially, if I were to sum it up in one line, right, it's shell scripts, but modern. What makes it modern is that it can automatically run on multiple hosts at the same time from like this like mothership control node used to like target multiple computers at the same time. And the other powerful part about it is that it's idempotent, so that if you run the Ansible script twice, right, it actually won't change the state because Ansible can detect that you have already provisioned the server, and if you try to run the same provisioning script, right, nothing will change. So it makes it like more error-free, so that you don't break stuff by running it twice, for example. Your Ansible scripts are also written in YAML, so it's very easy to read. And if you ever need to extend it for your own users, right, the modules are actually written in Python. So it's very easy to use. So this is what Ansible looks like. If you were to use it to replace your shell scripts, right, to do your provisioning scripts or your server management scripts, your shell commands are now written in YAML. So each Ansible module, it actually maps to a shell command or program like yum or apt or some kind of operation. So there's a module in Ansible called file that can handle file copies, file linkings, deleting files, moving files, symlinks, and all that. So on the right, you can see here what it does in these few lines. I'm running two tasks in this Ansible script. It installs Apache HTTPD, and it starts the service. So I don't know about you, but this is a lot easier to read than a shell script. And another useful feature of Ansible is the idempotency. So the modules, right, they are not just like they don't just blindly map to shell scripts or shell commands. They are actually like modules in Python that will actually check the state of the system first before they try to do anything. So for example, right, if you try to mount a drive, like you want to mount a device to a certain mount point, right? If you run this shell command twice, like 2 times in a row by accident, you'll result in an error. And then if this is one command in your very, very long shell script, right? If this fails, your entire script fails. Then you end up with your system is now in a broken state. However, right, if you use Ansible to mount, the module actually checks first if the drive is already mounted, and it skips if it's necessary. And it does it without you writing the if else. So what it looks like, if I were to write a shell script that like mounts a device, if I want it to be safe and like idempotent, I need to first check if the device is already mounted at some place. And so it's something like if else. So it's like if it's already mounted, if it's not mounted, actually mount it. And this is very hard for me to read. So I am not like an expert in like shell scripts. I need to check like how do you mount, how do you like check if a drive is mounted. And then the if else syntax is not very clean in bash. And then you also need to go and search like, oh, I forgot how to write if else in shell. Then you realize that this if else syntax, right, does not work for L shell, all the shell variants. There's the bash, There's bash, there's the original shell, and there's the ZSH and all that have different if-else syntax sometimes. Whereas with Ansible, right, it takes a more declarative approach. You just tell Ansible what is the state of the system that you want to achieve. So I want to say that if I run this script, right, I want a drive at this device to be mounted at this point. That's it. So if it's already mounted, right, Ansible will do nothing because it's already mounted. Your state is already what you want. And this also automatically adds to like the fs tag file without you doing weird things like echoing to the file and all that. So this is one very clear advantage of Ansible, where first the syntax is a lot more clean and expressive due to its declarative paradigm, and it's also idempotent, so that it's more resilient from recovering from a failed state, or you don't accidentally break your systems or leave them in a broken state because you run some parts twice. Another very cool thing about Ansible is the host inventory. So if you have your target from your own target host, right, like your control node, like your laptop, you can actually run the same Ansible script, or we call them playbooks, right, to target multiple hosts at the same time without opening the SSH sessions yourself. So what this means is that you can have like 100 VM instances in your Google Cloud project, and without you defining the IP address for the public IP address for each instance, right, you can actually tell Ansible to dynamically look up how to connect to these instances, and it does so by lookup plugins. So, for example, there are GCP plugins that can hook into Ansible to tell you things like oh, return me all the instances in this project, or return me all instances with this tag. So you can say things like, oh, I want to do apt-get upgrade on all the database servers, and your database servers only the database servers have a certain tag. So Ansible can actually just detect, like dynamically build this inventory of hosts, so that you can target multiple hosts without knowing the exact number of hosts and without knowing what is their exact IP address. So all of this is automatic, which will save you a lot of time. So what are some practical use cases of host configuration tool like Ansible? So let's see how we can actually use it on GCP. So we might know that on GCP, right, if you want to run like a web server, right, that receives a lot of web traffic, you can actually create like an instance group that scales the number of VMs in this group. So if you have more traffic that comes in, then it spins up more VMs to handle the traffic, to distribute the traffic among these instances. But the thing is, when you spin up all Google can do for you, right, when inside the instance group, right, is just start the VM. But actually installing Flask and like starting the Flask application, right, you still need to handle that yourself. So the provisioning in a web application, right, the provisioning process might look something like this. You want to first update all your software packages. You want to install Python, a certain version of Python. You want to git clone your project. You install your project's dependencies, and then you start the application server. So instead of writing one giant shell script, right, you could do something like this. You translate it into Ansible modules. So this is what it looks like to apt-get upgrade. You install Python. You clone the project. You install the project's pip dependencies. So like this is actually quite advanced. You can actually install it to a virtual environment and all that. And finally, you start the app server. So now you have this Ansible script instead of a shell script. It's you just need to run it on start. So the thing is, why we want to put a layer of abstraction between like the server setup script and this startup script that GCP gives you. So in GCP, right, if you define a startup script here, right, all your VMs will automatically run this when the VM is created. But with Ansible, right, what you can do instead is this startup script in GCP is the same for all your instances, but the contents of the playbook, the Ansible script, is different depending on like what role your server is serving. So now all your VMs, right, created from the auto-scaling instance group will automatically be up and running with the software that you need. So how does Ansible tie in with best practices? Inside the IOC, or infrastructure as code paradigm, right, or inside, if you're using a IaaS, right, infrastructure as a service, the host operating system that your application runs on, right, is now actually part of your application code and should be treated as such. So for example, if your application runs on a specific version of Python, then the fact that it runs on this specific version of Python needs to be versioned together with your code, like inside your GitHub repository. So your GitHub repository should contain things like, oh, what are the apt packages that are needed to run my application? So once you have the Ansible playbook, it's just a YAML file. You chuck the YAML file inside your Git repository, and there, your infrastructure is now versioned. And having this automatic provisioning process whenever your server starts up, right, it also ties in with this other ideology in DevOps of cattle. It's called cattle, not pets. So what it means is that you see your servers, right, as replaceable and disposable. It's like they are cattle. You can just like kill them and breed them again, and not pets. So if you are able to like make this setup process very consistent and reproducible, then your VMs are now like very easily replaced in an instance group. And inside an instance group, right, if you want your application to be scalable, they need to be created and destroyed consistently and easily. So some other uses of Ansible is that Ansible can be used for a bit more complicated host configuration steps, where again consistency is important. So every time you run it, it produces the same output, even if the state is slightly different. So you can use it to do things like you set up firewall rules and you mount devices. It's also great for managing like the state of monolith servers that are running multiple services on the same VM. So sometimes you're just the infrastructure guy, you're not the developer. So your dev team actually gives you an application, but it's designed to run as a monolith. So there's nothing you can do but like you can't tell them to use Docker because you're not the one who built the application. So what you can do instead is to make your own life managing the monoliths a bit easier. It also runs great for both like on-premise VM clusters or even bare metal instances. So it doesn't just work on the cloud. It works for pretty much any Linux host, or I think it might even work on Windows hosts. So this is just my experience, but like legacy applications, it is also quite useful if you're deploying like legacy applications or enterprise environments where they demand a VM instead of containerizing applications into microservices. So when I tell my friends about Ansible, like, hey, you can use it to automatically install the software on your host and manage the state of the operating system, then they always shoot back with this question: why not use Docker? So to me, Ansible and Docker are quite different things. I see Ansible as a way for you to it's like automated host configuration. Docker is more of containerizing apps. But you see, like as a developer or as an engineer, you need to choose the right tool for the right job. So if the only automation you need, right, is like actually like installing libraries and starting services, and less of like at runtime host level changes like swapping drives on the go, right, you should consider containerizing your apps instead. And this is quite relevant to the discussion of when you are moving your apps to the cloud. Do you want a platform as a service like App Engine, or do you want a infrastructure as a service, like you actually have full control over the VM? And then again, as for the previous point, Ansible is a bit more flexible than Docker. You can actually use Ansible inside Docker, but other than that, Ansible can target. It is a bit more agnostic in the sense that it can target both VMs in any cloud provider, not just GCP, or it can target your regular VMs that is running on your on-premise site. So actually, that's all I have to say for today. I hope that I convinced you that Ansible is a very cool tool. And yeah, I encourage you to try, and if you are working in the infrastructure role where we're looking to automate some of your provisioning steps or your setup scripts, right, or managing state, try using Ansible, and you can see that it might actually make your life easier. So thanks for listening to my presentation. I'm Chester again, and this is my LinkedIn if you ever need to contact me for whatever reason. So yes, thank you.